Let's do problem 23 on page 243, and here it is. It says, a force acting on a particle moving in the xy plane is given by F equals 2y in the I hat direction, plus x squared in the j hat direction in newtons, where x and y are in meters. The particle moves from the origin to a final position having coordinates x equals 5, y equals 5 as shown in the figure, which we'll draw in a minute. Calculate the work done by the force when you go from OA to C, and then from OB to C, from O to C directly. And D, is the force conservative or non-conservative? And please explain why. So here's the picture for this problem. So we'll reproduce that here. Now, so here's what's given. We have a force that's applied, and it says that the force is 2y in the I hat direction plus x squared in the j hat direction. And of course this is in newtons. And we're also given this diagram like this, where this is 5 and this is 5. So this is x and y in meters. So this is 5 meters and this is 5 meters. We're going to make this O for the origin. And then this is point A. And then we're going to make point B right here. And then point C is our final position, which is at 5 meters. Okay? And what we're trying to find is we want the work done if we take the following path, which is from O to A to C. O, A, C. And then for part B, we want to know how much work was done if you follow the path OBC, I believe, right? And I'm just, I make up subscripts, okay? Work, OAC, all right? That's just, it's a shortcut way of writing it. And then we're going to find the work going directly from O to C. That is like this. So from A, we're going to go along this path and along this path right here. And then and then part B, we're going to go along this path and then along this path. And then in part C, we're just going to figure out how much work it takes to go directly like this. That's the real tricky one. Well, let's solve this. Well, work is equal to the integral of f dot ds. S is a little tiny path length. Sometimes we use dr, sometimes we use ds, whatever you prefer. And so let's do this for part A. Now, remember, this is a sum, so we're going to add up things. And so you can break up an integral. When we go from O to A, and then we'll go from A to C. So we're going to break it up into two parts because there's different things going on. And so you can easily break it up into two parts. So we'll say that it's the integral of f, which is 2y I plus x squared j. And if we're going from O to A, I'll just go from O to A. I'll just write it like that. Now, if I do this, and then dot, well, we'll just go ahead and say ds, but that's going to change here in a second. Look at this. If I go from O to A, what is true about y? What is true about the y value along this path? It's 0, so this whole term goes away. Now, what's true about ds as I'm going along here? Just draw a little tiny displacement vector, ds. Well, it's all in the x direction, So ds is really equal to dx I hat. Do you follow that? Okay. And you go, okay, well, all I've got left is in the j direction. Yes, the force is increasing as x increases, but it's in the y direction. The force, as I go along O to A, the force is all in the y direction, but my displacement is all in the x direction. So there's no work done. Or you go j dot I is 0. So when I went from O to A, no work was done. So now we're going to add 0 to, well, now we're going to go from A to C. That's going to be my path. So I'll go 2y I hat plus x squared j hat. And now ds, what is ds going to be? Well, draw a little differential element. It's going to be all dy in the j hat direction. So I'll say, okay, dy in the j hat direction. Well, here's what I know. If I go I dot j, I get 0. So this term doesn't matter. So all I've got left is j dot j is 1. So I get x squared dot j. Now, what's true about x as I go along from A to C? X is constant, isn't it? It's 25. So that comes out of the integral. X squared, well, it's 5 squared, so it's 25. And now all I've got is the integral of dy from 0 to 5. Well, what is the integral of dy from 0 to 5? It's just 5. Right? You just add up all the little dy's, and what are you going to get when you go from here to here? You're going to get 5, a length of 5 meters. You see that? And so 25 times 5 is 125 joules. And so that's my answer to part A, because when I went from O to A, it was 0. And when I went from A to C, it was 125. 0 plus 125 is 125 joules. Is that right? Can someone check the answer? That's right? Okay. Because every once in a while, I totally blow it. All right, here's part B. We're going to go through the same thing now. We're going to go from O to B. And I'm going to say this is 2y I hat plus x squared j hat. And if I look at my little ds's, they're all in the y direction. So this is going to be a dot dy in the j hat direction. Well, notice that if I go I dot j, that's 0, so this term doesn't matter. When I go j dot j, I get 1, but what is x as I move along this line? X is 0 the whole time. So the whole thing is 0. Why? Because x is equal to 0. And this is I dot j is equal to 0, so that multiplies to 0. So now I'm going to go from B to C of 2y I hat plus x squared j hat. And if I draw my little dy here, or it's actually a little dx there, isn't it? There's little dx's as I go across there. And of course, so this is going to be dx in the I hat direction. So because I'm going in the I hat direction, this doesn't matter, right? Because j dot I is 0. I dot I is 1. And so, and what is y this whole time? Y is just equal to 5. So 2 times 5 is 10. So this is going to be equal to 10 times dx. And what is x going to vary? It's going to go from, x is going to go from 0 to 5. And so this is just going to be 10 times 5. This is going to be 50 joules. And so my answer, when I go from O to B to C, is 0 plus 50 joules. So my answer is just 50 joules. Now I can already answer, I forgot about part D up here. What was part D? Is it a conservative force? Is this force conservative? And the answer, I can tell just after doing A and B, the answer to D is no, it's not. Because what would have to be true if force F here was a conservative force? Yeah, it wouldn't matter what the path is. If I went from O to A to C, it would take the same amount of work as going from O to B to C. All right. Now, probably, so the answer to D is, I'll just put no. And they have to explain. So please write out in words, because the work is depends on the path. Now, probably what you're most concerned about is part C. How do I do this? Well, here's a hint. Here's my ds vector. Let's look at ds. So this is part C. My ds vector has a dx in the I hat and a dy in the j hat. So what I can do when I do the integral, and I'm going to go from O to C, I'm going to write 2y I hat plus x squared j hat. I'm going to dot it with dx I hat plus dy j hat. So in other words, my differential element is broken up. Also, in order to solve this, you have to notice something. What are the values of y and x as you go along here? They are the same thing. In other words, y equals x. You have to see that in order to solve this problem. Now, the bell is going to ring, so I'm going to stop now. I'm going to leave you to finish that on your own.